Most students will rush this question and use the wrong theorem, but today I will show you the smart way to solve it step by step. In the diagram, A, B, C and D are points on a circle. A, B, C and D are points on a circle. Line AB is parallel to DC. Line AB is parallel to DC. Line AC and line BD intersect at X. Line AC and BD intersect at X. And angle BDC equal to 40 degree. Angle BDC is 40 degree. Find angle ACD. Angle ACD and also angle AXD. Angle AXD. Since line AB is parallel to DC, our line BD is a transversal. So our angle DBA is equal to our angle BDC because they are alternate angle, and alternate angle equal to each other. So we can say angle DBA is equal to angle BDC. Angle DBA equal to our angle BDC is 40 degrees. So 40 degree. Angle ACD and angle DBA are angles on the same segment standing on chord AD, and they are equal to each other. So angle ACD is equal to angle DBA. Angle ACD equal to 40 degree because our angle DBA is 40 degree. Let us consider triangle DXC. In triangle DXC, angle AXD is an exterior angle of triangle DXC, and the exterior angle of a triangle theorem says that the exterior angle is equal to the sum of two opposite interior angles. So it means that our angle AXD is equal to our angle XDC and angle XCD. So we can say angle AXD is equal to angle XDC plus angle XCD. And in our diagram, our angle XDC is 40. Our angle XCD is also equal to angle ACD, which is 40 degree. So let us substitute them into this equation. Angle AXD equal to 40 degree plus 40 degree. So angle AXD equal to 80 degree, because if we add 40 degree plus 40 degree, it will give us 80 degree. If you use only one theorem here, you would definitely miss it. Circle theorems require combining concepts. If this helps you, like, subscribe, and keep learning with Teacher B. Thank you.